You know that feeling when you walk into, like, a massive sports bar or a stadium concourse,
Yeah.
and there are just 54K displays on the wall?
Oh, yeah, and they're all playing different live feeds completely flawlessly in sync.
Right. It feels like magic, but the reality is actually just ruthless, highly engineered network infrastructure.
Yeah, no buffering, no dropped frames. It is all hardware. So welcome to today's deep dive, where we're looking at the invisible backbone making all of that happen.
Exactly. And we are pulling from some product specs over at HDTVSupply today to examine this tiny, um, unassuming device called the Atlona AXM763 SFP plus transceiver.
It's quite a mouthful, I know,
Uh,
but it is basically the brainstem for these massive commercial AV networks.
right, because to push that much high-fidelity video, like what you see in OmniStream AV over IP
Wow.
systems, you need massive 10 gigabit Ethernet links connecting everything.
Yeah, all those network switches need to be linked so they can operate as one unified system.
Okay, let's unpack this, because if we're talking about massive 10 gigabit networks running on these NETGEAR switches, my first question is, why do we even need a separate plug-in module?
Right, like why not just build it in?
Yeah. Why wouldn't a commercial switch just have fiber optic ports baked right into the chassis to begin with?
Well, it really comes down to flexibility and risk management. The AXM763 is an SFP plus module, which stands for Small Form Factor Pluggable.
Oh, got it. Pluggable being the key word there.
Exactly. If a manufacturer bakes the fiber ports directly into the switch, you are permanently locked into whatever specific fiber standard they chose at the factory.
Right, which sounds like a nightmare if standards change.
It is. Plus, if that one single port burns out for some reason, you have to replace the entire expensive switch.
So using modular slots makes the switch totally agnostic. You just slot in the Atlona module when you need to jump to a high-speed fiber connection.
You've got it. Mechanically, the switch itself is just processing normal electrical signals, so this transceiver acts as the actual physical converter.
So it takes those raw electrical data streams from the
Mhm.
switch chassis and, like, physically modulates them into pulses of laser light.
Yeah, exactly. It blasts them out through what's called an LC duplex connector.
Okay, LC duplex. Duplex means two. Yeah. So since we're dealing with immense amounts of continuous video data.
Right, so duplex basically means we are looking at a two-lane highway. There is one dedicated fiber lane for transmitting the light and an entirely separate lane just for receiving it.
Which ensures zero data collisions.
Exactly. And crucially, the specs note it is fully compliant with SFP plus MSA standards.
Multi-source agreement, which basically means the tech is universally standardized across different manufacturers.
Yeah, and that allows for hot swapping, which is absolutely vital for commercial environments.
Because of that MSA standard, if a module fails right before kickoff at a sports bar, an engineer just pulls the bad module out and snaps a new one in, right?
Yes, the switch stays powered on, the network does not drop, and
Yeah.
the patrons never even miss a play.
That is wild. Here is where it gets really interesting, though. We all know copper degrades over long runs, which is why enterprise AV relies on fiber for distance.
Right.
But the specs here outline a massive variance in just how far this specific module can push that 10 gigabit signal, depending on the literal glass you plug into it.
What's fascinating here is the physical mechanism behind that variance. So the module operates over standard 62.5 or 50 micrometer cables.
Okay.
If you use multi-mode fiber, it pushes that 10 gig data flawlessly up to 220 meters or even 550 meters on higher grades.
But multimode physically allows the light to bounce off the walls of the glass core as it travels.
Right, and over longer distances, those light pulses start to blur together. They call that dispersion.
So the signal just eventually gets muddy.
Yes. But if you swap the cabling to single-mode fiber, the glass core is incredibly narrow. The light doesn't bounce at all.
It just shoots straight down the middle in a single tight beam.
Exactly. And because there is virtually no dispersion, this exact same Atlona transceiver can suddenly push that 10 gigabit signal a staggering 2 kilometers.
Wait, you're telling me I can push a 10 gigabit signal across a campus the size of a small town without a single hiccup in the AV signal just by swapping from multi-mode to single-mode fiber?
That is exactly what I'm telling you.
That is 1.2 miles. You could link multiple network switches across an entire university campus, pump uncompressed 4K video between buildings, and the displays react as if they're plugged in 3 feet away.
Yeah, it's incredible. When you step back, the big takeaway for you here is that managing information overload in commercial AV is not just about clever software routing.
Right? Software is only half the battle.
Exactly. It demands precise, hot swappable physical hardware to physically bridge isolated networks together. It's all about translating electricity into light so multiple systems can operate as one massive brain.
Man, so what does this all mean for the future? We're seeing commercial displays getting hungrier for data every year, pushing 8K and beyond.
Oh, absolutely. The data demands are only going up.
Which leaves you with this to ponder. If these tiny transceivers can effortlessly shoot 10 gigabits of data over a mile using tight beams of light, how long before this enterprise-level commercial technology stops being a luxury and becomes the baseline standard for replacing the messy copper wiring inside our own smart homes?
Now, that is a really good question.